Okay, so here's a problem we see come up pretty frequently. How many distinct arrangements can be made from, and they'll give you a word. Now, we're going to start with something easy. We're going to start with coal. Now, what they mean by the number of distinct arrangements, I can rearrange this word, this name. I can write it as it is. That's one arrangement. I could write C-L-O-E. That's another arrangement. I could do E-C-O-L. That's another arrangement. I could keep going. I don't want to do that. That's going to take a while, okay? So there is what is called the counting principle. This is an important thing. I have 4 spots to fill, right? Because I have a C, I have an O, I have an L, I have an E. So in the first spot, how many choices do I have? I can use the C, I can use the O, I can use the L, I can use the E. So in the first spot, I have 4 choices. Then I multiply that. Well, I've now taken 1 letter away. How many choices do I have for the second spot? I'm down to 3. Then I've taken 2 letters away, so I have 2 choices for the third spot, and then I have 1 choice for the fourth spot. So I multiply all those. 4 times 3 times 2 times 1, that's 12, times 2 is 24, times 1. So there are 24 different ways to rearrange the word or the name coal. Now, when you take a number and you multiply it by everything below it, that's called factorial. 4 factorial is 4 times 3 times 2 times 1. So if I want to know how many different arrangements can be made from Ethan, well, that has 5 letters, so that would be 5 factorial. 5 times 4 times 3 times 2 times 1. So that would be 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120. So there are 120 ways to write the word Ethan when you rearrange the letters. Now, what happens if any of the letters repeat? Why does it matter? Well, let's take my name, Mickey, M-I-C-K-I-E. I have 2 I's in my name. So I can write it like this, and that's one arrangement. But if I swap the white I and the pink I, sorry, I got interrupted. I don't remember what I was saying. I think I was saying something. If I swap the white I and the pink I would get this, which is the same thing, right? It's different because 2 of the letters have been swapped, but this is not distinct from this. We could not tell these apart if I didn't have the letters colored. So we have to take those repeats out. So here's what you do. You count the number of letters. I have 1, 2, 3, 4, 5, 6 letters in my name. So that would be 6 factorial. And then you divide by the number of repeats. 1, 2. I is repeated twice. So you divide by 2 factorial. Now when you divide factorials, you're looking for things that cancel. 6 factorial is 6 times 4 times 3 times 2 times 1. Over 2 factorial is 2 times 1. Well, 2 over 2 cancels, 1 over 1 of course cancels, and I'm left with 6 times 4 times 3. That's 24 times 3, and we know that we don't have a calculator at a math tournament, and we get 72. So there are 72 different ways to write my name that look different from each other, that are distinct. So let's look at Hannah. Hannah has 1, 2, 3 sets of letters that repeat. The H repeats, the A repeats, the N repeats. So we count how many letters. 1, 2, 3, 4, 5, 6. That's always the numerator. So 6 factorial over, she has 2 H's. so that's 2 factorial. She has 2 A's, that's another 2 factorial, and she has 2 N's, which is 2 factorial. So we do 6 times 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1 times 2 times 1. You've probably figured out by now you don't have to write that 1 because it doesn't really affect anything since you're multiplying by 1. Now you look for things that cancel. These are gone. These ones I don't care about. This 2 goes into 4 2 times. This 2 goes into this 3 times. And I end up with 3 times 2 times 3, which is 6 times 3, which is 18. Notice, because of all the repeats in Hannah's name, there are fewer ways to write it that actually look different from each other.